Hello, ContainerDays. We are going to show how to get from bare metal to KubeVirt in only 10 minutes. At least that's what we tried. Who are we? First, my colleague Usman is going to introduce himself.
Hello, everyone. My name is Usman Malik. I'm 33 years old, having a kid on the way. I'm originally from Pakistan. I'm living in Hamburg for about 8 years, fell in love with this city. That was my first city in Germany. So I'm a DevOps engineer and a cloud native engineer by day, and I'm a cook by night. I love to cook and eat. I started as an IT and a security researcher. I did a lot of bug bounties, but I got married and I don't have time. No, I'm just kidding. Now I like cloud native too much. If you want to follow me on LinkedIn or Twitter, you can follow me. And what about you, Robin?
Hi, I'm Robin. I'm a product owner at the German Edge Cloud. I'm 30 years old. I'm married. I have 2 kids. I'm living in the middle of nowhere in Büdingen, which is near Hanau. Does someone know Büdingen? No, I thought this would happen. I'm a product owner by day and a software engineer by night. I still like to code, and I started as a DevOps engineer at German Edge Cloud in 2020, but I obviously liked Excel too much, so I become a product owner. Who is German Edge Cloud? So we're all about cloud automation software. We were founded in 2013. That's an issue where we started with OpenStack as a service. We are a Gaia X founding member. We have offices in Eschborn, Limburg, and Berlin, and our daily job is about innovating in edge computing and hybrid clouds. After this short introduction, so why are we talking about Metal as a service and KubeVirt at all? We faced some issues with our edges at customer side. So we used to use OpenStack on Kubernetes, which is handy for some stuff because you can easily scale up by adding worker nodes, but we faced some issues with that. For example, deployment and update speed. We would like to improve. We are talking about days, not about hours, what we would like to do. Lead time for new features is very high because you have a very complex set of features. You need the hardware needs to support the feature, your hypervisor, up to the VM. And we are with our setup. That's our issue. We are very tied up to a specific hardware vendor, and we want to have more independence here. And one request we have from our customers is they want to use containers as well as virtual machines, because a cloud native way is good, but not everyone is ready for it. So that's the challenge too. And we need a more modular infrastructure and configuration, because each customer is different, each environment and infrastructure needs to be tied to be made specific for the use case, and we need to improve here. Next slide, please. Yeah, maybe we should do something about our solution here, Usman.
What are the requirements?
So I think it can't be this hard as a product owner. Yeah, Usman, we just need a scalable hypervisor. We need some network isolation. We need a fully automated process with our netbox inventory, PCI pass-through for GPUs, for example, an easy upgrade path. Deployment should be in about minutes, not about days, and everything needs to be cloud native. It can't be this hard.
Well, that's quite a lot of requirements. I mean, yeah, as a product owner, you would say it's not too hard, but okay. We've talked about some other ideas in the past, but I have a brilliant idea. Just forget about the other ideas and everything that we have done. I've basically got to introduce you to Mas and Juju. That will solve some part of the problem, and the other problem is going to come later. So let's deep dive into Mas, how it can help. So Mas basically has a region decontroller. You can think about regions as a building, as an availability zone, like Berlin, Hamburg, Hessen, whatever. You can think about those as availability zones. It consists of a database, Postgres, and a region decontroller, which sets the gateways to the rack D, which you see down there. So the RACD are stateless services, and they provide the services to your local rack, if you think from a bare metal and data center perspective. So what it provides is PXE, TFTP server, and also the images for the operating system. So it's local for your rack, and it's as fast as possible you can provision. But you might ask that this is horizontally scalable. You might ask that if rack D is broken or something, then the region D controller sets the gateway to a different rack D, and you can still get and boot from a different rack D controller. So that's how it looks like. The rack D is there. You have the switches, your machines are connected to the switches, and then on the right side, you see that you have your RAM, your CPU, your usual stuff that you have in your bare metal, and then it goes from an inventory stage to the provisioning. You can use cloud in it to provision, and then you have your operating system, and then you decide to do things on top. Now, talking about Juju, Juju is basically, now we have a bare metal with an operating system with a generic cloud config, and now we want to install things on top. So you can use Juju CLI, Juju Deployer. It all talks to the API, which is basically a stateless service. The state is stored in MongoDB, and then it talks to the controller workers, which basically installs the stuff. So Juju can not only install while being integrated with MAS, you can also integrate with major hyperscalers like AWS, GCP, VMware, even OpenStack. You can even add Kubernetes as a cloud provider as a configuration to your Juju, and then bootstrap your stuff. So, how does it sound to you? Does it sound too good to be true?
It can't be that easy. You always say it's that easy.
Yeah. Typical product owner. All right. So let's find that out. Let's have a look and see how does this thing looks like for real. So this is basically our Juju. MAS controller. And now what we did in the MAS controller, we also installed an LXD host where we created a VM for the Juju itself. You can do that in a separate machine, in the cloud, anywhere. We have some subnets here for Ceph data traffic, for Kubernetes traffic, Fabric for the LXD containers. And these machines already exist there. So what is the first step? The first step will be we want to erase the machines to complete blank state, which is what is happening now. So it's going to erase the disk, it's going to reboot, it's going to load an ephemeral environment. And just to give an overview, this is how the machine looks like. It has 225 gig cards. One is connected to the Ceph traffic, one is for the Kubernetes traffic. All this configuration is done automatically by MAS because we have subnets there. It boots via PXE. And yeah, so it's performing a PXE boot right now. It's loading the ephemeral environment. It's going to install the operating system, configure based on the cloud config that we have provided, and then it reboots, and then you have a machine. So it's going to go into a ready state. So you can see it's already deployed. We've got the interfaces, we've got the storage, one disk, NVMe disk. We kept it empty. We didn't provision it because we want to use that later for Ceph. And the other one is used to install the OS itself. So let's try to see how we're going to use Juju to deploy the bundle on top. We have 3 machines. We're going to come to that later, which we add to Juju. Then we have the applications where we define the applications we want to install. For example, we want to install for this demo one control plane, 126 version of Kubernetes, and we want to have 2 workers with 126 version of Kubernetes as well. Then we are just assigning this to the machines we want to install, and then it's etcd, and then kubeOVN is what we are using as our choice of CNI. We'll come back to that later. For the CRI, we're using ContainerD, and then we have the Ceph OSD and Mon servers. And you can see we have some relations as well, which is a Juju way of talking to the services, which service can integrate with what, can talk with what, and so on and so forth. So the first thing we want to do is we want to add machines to Juju. We basically have machines in MAS provisioned. And this is just a script. And it fails because we don't have a model yet. So Juju has a concept of models where everything can talk with each other when it's deployed. You can create a different model. It's an isolated workspace, but you can also make them work together. But it's a little bit complicated from the network point of view. Let's go ahead and create a model and verify that our model is created. Our model is there. You can see from the asterisk sign, that's the current model where we are switched to. And I'm going to run that script again to add the hosts to Juju. On the right side, we basically have Juju status command shows you the status, and we can see the first machine is pending, where it basically installs the Juju agent on it. So the machines are provisioned via SSH. The Juju controller has SSH-based authentication with a sudo no password, and then it installs everything there. Now, using the Juju deploy, we basically specify the bundle, which we saw earlier, and we use option here, map existing, because Juju is able to bootstrap new VMs for you as well in the cloud, but we want to use it to the existing machines. Deployment done on the right, on the left, on the right side, we see now it's pulling stuff. So it's in the maintenance mode, it's allocating, it's installing the Charm software, and Charms is something which you can find on Charm Hub, something like Artifact Hub for Helm, for example. And you can see from Canonical, from the community, there's a lot of things available that you can install, especially Kubernetes, which is a certified distribution from Canonical. And the cool thing is, if you're installing Kubernetes and you're installing Ceph on top, it does the integration automatically. Now we can see Ceph is already installed, and we just went to one of the machine, we did a Ceph status, and we can see we have 3 Mon servers, we have 3 OSD servers with 2.6 terabyte available, which is something what we expect. So Juju is really easy when it comes to installing stuff, having integrations with your stuff. You can even write your own Juju charms. And we're still waiting for the control plane and the workers to come up. But this is just an example for the demo here. We just are using one control plane, which means if you upgrade or bootstrap, of course, the clients will not have the connections. In a production setup, you want at least 3 control plane nodes with a load balancer on top. And so that when you're doing a maintenance or rolling out new versions, your clients can still talk to the Kube API. So it seems like from the right side, etcd and control plane is ready, and we can already see the other 2 worker hosts, and they all are running 126.8, which is what we specified in our Juju bundle. Now, some pods are still coming up. You know, it's just new workers. It's simple stuff. And those pods are going to come up in a couple of seconds, and we basically have a running Kubernetes cluster with 1 control plane and 2 worker nodes. What do you think about this, Robin?
This looks pretty handy, Usman. But to be honest, as far as I know, the hard part is always about the day 2 operation stuff. So how do I update it, for example? Is it possible to have an easy upgrade path for Kubernetes here?
Absolutely. It's pretty easy to upgrade. It's all about changing the version that we specified in the bundle file earlier, which we're going to see that in a bit. We just changed that from 126 to 127. Let's also find that out. How does that look like? So here's the bundle file we saw earlier. So all I'm doing here is changing from 126 to 127. You can also pin down to a particular minor version in there as well. And what I'm doing now is I'm just doing a Juju deploy to deploy that bundle. So it's going to take a while, talk to the Juju controller, see the state that it has currently in the database. But what you can do is you can also create overlays on this bundle. So you could define a generic Juju bundle, and you can specify overlays like, I want to have Calico as my CNI. I want to have my Flannel as a CNI or Cilium as a CNI. And all of this you can override on top. So as you can see here, the upgrade was triggered, but it required a manual action. So what I did here, I ran the command juju run Kubernetes worker 0. It's updating the worker first, and we can see that the first worker update was successful. And now I'm going to do the worker upgrade for the other worker that I have. And this will, of course, also install kubeproxy, kubelet, all the other services that are required. Let's log into the machine and see how it looks like. And we can see both of the workers are actually upgraded. So they're running 127. But our control plane is still running 126, which is something we want to do that as well in the end. So everything looks good. The pods are scheduled back. They're all running. And let's go ahead and upgrade our control plane. And the control plane upgrade started, so we can see that it's at the moment in the block state, and now it's in the maintenance state, and then it goes to the executing state, where it pulls all the components it needs to install, like Kube API server, control manager, Kube scheduler, kubelet, and so on and so forth. But as mentioned earlier, since it's just one control plane, just for the demo purposes, because it takes a lot of time for the other components to bootstrap, we will lose the connectivity to the Kube API. And we're going to see that in a bit when we're going to run kubectl get, for example. Takes a while. So, okay, let's go and log into the machine and let's verify what's going on. How does it look like? So it's still on the version, I think 126.8, but the reason is it's still configuring and restarting it. So you also see here Easy RSA, which is an open source tool, what it uses to bootstrap the PKA infrastructure and then get and release and get new certificates. And now it's basically restarting the kubelet, which is why we can see now it's not in ready state. And there we go. Now we have a 127.5 running control plane, and all of our nodes are up and running, and all the pods are scheduled as well. The one pod that you see in pending, don't worry about that, because we just have 2 workers, and by default it needs at least 3 workers, because we defined in our configuration we need 3 units. So this is why you see 1 CSI for RBD plugin in pending state. But that's it. We have a working upgrade for the control plane and the worker.
Okay, maybe this one was too easy for you. We need to spice it up. So one question I always get from our customers is, what about network security? What about network isolation? Because the edges we sell right now, they have projects, and the projects are separated by the network. So because they have external partners, for example, they want to onboard, and they should not be able to access internal projects at all. That's always kind of hard. How would you solve that?
So there's a lot of ways that you can solve that. And the small story which I want to talk about is we've been looking at KubeOVN, KubeVirt, these technologies for about a year now, because we want to have a cloud-native edge where we can run cloud-native VMs along with the container workloads. So we've been in touch with the community as well from the KubeOVN. And it's just a CNI which you can use to have VPCs inside your Kubernetes. You can have different subnets that you can assign to the namespaces, and you can think about namespaces as customers or tenants in a multi-tenant environment. You can do a lot of things, depends on the requirements that you have. And you can also have ACLs on top. And it works really well, because you mentioned about security and observability. It works really well with Cilium as well. It has a really tight integration with Cilium if you want to have some sort of encryption or anything like that in between. And the other thing that we wanted, or our customers wanted, was VMs. And we've been using other virtualization technologies to provide VMs to the customer, but our customers are moving to cloud native, and they want to run their legacy applications in Kubernetes alongside their containers. And the right answer to this was KubeVirt, which is also something we have been following for about a year and a half. And I think a few months ago, it was now a general availability with V1. And we gave it, again, a shot. And the meanwhile, we were just, going to and forward and seeing if it works or not. And it did really work and has really nice integration with KubeOVN. So this is how, the KubeVirt architecture looks like. So we all know about kubectl and an API server. But what it does, it installs a Virt controller and Virt API. And then it has another component that's talking to the API, Virt API, which eventually talks to the Kubernetes API and the kubelet. The Virt handler basically is the one who talks, and it's basically a daemon set. So it's running on every worker node or control plane, depends on how you've set up. And then it creates a pod called Virt Launcher, which basically talks to the libvirt API, which eventually talks to the KMU API. And then you eventually get a VM. And you can run your VM as a separate workload along with your containers, or talk to the other containers or other Kubernetes workers themselves. And this gave us really, really good flexibility, because there's still customers out there who have software licenses that are tied to a UUID, and those applications only work. And for such use cases, I think KubeVirt is a great choice for the requirements that we have. So let's go ahead and see kubeOVN and KubeVirt, how they work together. Oops. All right. So we have two namespaces. Well, we just create those two namespaces. This is how a subnet looks like. So you specify the name, you specify the protocol that you want to use. You can assign a subnet to a namespace, which we did to NS1. Then we have a CIDR block that would be any CIDR block that doesn't collide with anything else. And then we have the gateway IP, and we exclude that IP. Here, private true means it's a DMZ, so it cannot communicate or talk anywhere else. And you can have separate gateways as well. You can also NAT the gateways. You can do a lot of things with it. And the other subnet that you see is pretty identical to the first one. Let's go ahead and create the subnets. We already have the namespaces, and let's go ahead and verify the subnets. So here we have two subnets, NS1 and NS2. Both have the same CIDRs, what we define. Both are private, which means they are DMZ. They can't talk to each other, neither any other Kubernetes services. If you want to do that, you can use ACLs to talk to the other Kubernetes services or have cross namespace communication. And for the VM part, this is the custom resource for KubeVirt. You have the spec where you define the state of the container. So you say running true. By default, in the examples, it's false. And then you can also have flavors in KubeVirt, like you do in any other cloud provider or OpenStack. You can say T2 micro, M1 micro, blah, blah, and you can assign those labels and the domains. And of course, you can have the same requests and limits for your VMs as well, just like you do for your pods and deployments. And here we're just using a 0S image, but you can create your own image. You can also create OCI image that has your own custom ISO in there. And it will just work out using the CDI, Container Data Importer. And the other VMs looks identical. So let's go ahead and create those VMs in the two namespaces. And it doesn't work because I guess we forgot to install KubeVirt. So let's go ahead and install KubeVirt first. And this is just taken from the official documentation, just simple set of command that installs the KubeVirt operator, that installs the KubeVirt CR to bootstrap the instance of KubeVirt, and then installs the virtcdl, which is just the client that you would use to connect to the console of the VM. You also have a kubectl plugin for this. As we can see on the right side, we have the operator there, and we also have the KubeVirt instance here. It's in the state deploying. Looks good. We can see Virt API connected. This is something similar to what we saw in the previous architecture as well. Let's go ahead and try to create the VMs. And it failed because it's still bootstrapping services and it does not have the webhook calls. So now we can see in the previous architecture, if you guys remember, we had the controller and the handler is responsible to create the VMs, and controller is basically talking to the other components and the operator, including a validating webhook inside. Now the VMs are created, and they are already starting because we have in the spec as running true. So let's go ahead and see how they look like, and they just look like regular pods. How we basically have the other pods and deployments. And we can see here we have a different subnet with the CIDR block that we defined. So it's starting from 10.11.12.2 and so on. And we excluded the IP1, which is our gateway IP. So now we have the running VM. Let's go ahead and try the console in the running VM and see how that looks like. Typo. Right, we have the console. So I'm going to log in with the default 0S user and the password, and then I'm going to just verify some stuff here. And let's try to ping the other VM in the other namespace to see if we really have the isolation. So we see some IP address here, the gateway, and we can ping the IP of the VM itself, but we cannot ping the IP of the VM in the other namespace, which is what we actually wanted as per our requirements. We wanted to have a pure isolation. Think about NS1 and NS2 as two different customers in a multi-tenant environment. We do the same with the other VM, and you might ask a question, why do you have a different IP assigned to a pod and you have a different IP inside the KubeVirt? It's because, if you remember, there's a KubeVirt launcher, which basically launches the VM, and it creates a NAT gateway between the actual VM. So that's the one who's talking to the libvirt API, and then it has NAT internally so that it has a different IP range. And now we can't ping the other, but we can actually ping the IP of the VM itself. This is exactly how we want it. The other thing is, the DNS service configured inside actually points to the Kubernetes DNS, which means if you have your application running in a VM and you have a, let's say, your database running cloud native PG operator, let's say Postgres, you could still connect and talk to them. So this is exactly what we wanted, and it really works for us. And this is something what we're thinking to take it, to the next level. What do you think about this, Robin?
Pretty good work, Usman. This helps me to satisfy our customers. So we now have 3 minutes 50 for a short sum up. So I will present you what components we used in our talk and what our summary is about them. So the first thing we used was Metal as a Service, which we can only recommend. It makes hardware just feels like virtual machines because you have this thin layer which is API based, so you can easily automate it. It helps us to get more hardware independent because some customers want our hardware, some bring their own. We can do both with it. Then we have Juju, which is also API driven. I mentioned that because before that we had built this with Ansible, which was it has its pros and cons. We like this API driven approach more, and we can easily install, update, and upgrade our clusters. Then we have Ceph, of course. I think most of you know Ceph. I don't need to talk much about this. Then we have KubeVirt, which is pretty impressive for me because it helps us to have cloud-native VMs in some way. And we have one Kubernetes cluster to fulfill both needs of our customers, containers and VMs. And we can use the same container-native, cloud-native tooling. And you don't have this knowledge gap if you have, for example, Kubernetes, and you have stuff like VMware or OpenStack. The tools have very different APIs, and with KubeVirt you have nearly one API to use it for all. And you have KubeOVN with all that network isolation magic, which helps our customers to satisfy their security needs. So after all, Usman, I'm pretty confident with that solution. And thanks for you and your colleagues, Georgie's work. Not to forget. And yeah, that's it for our talk. Thanks for joining us. You can visit us at the booth to have a private presentation about that. And of course, you can ask Usman every technical question and me some questions about Excel and PowerPoint. Thanks for listening.
By the way, you can still ask the questions. You don't have to look it up in Google or ChatGPT or something.
Okay, thanks a lot for this amazing talk. We have a few questions, as you can see up there. The first one is, and I wanted to ask this one, so it's fine. What is the difference to Gartner?
So yeah, that's a really good question. So Gartner, yeah, that's also an open source solution which you can use to have unified control plane as well, and you can bootstrap your other environments based whatever you want. But what we wanted is we want to, not use something. We are dealing with some customers that needs some solution that is, that they can trust. I'm not saying that you can't trust Gartner, but it's completely different to the requirements that we want to have. And it's not just KubeVirt or the OVN that you can install with Gardener. It's just different requirements that didn't meet. But we did an evaluation to find that out.
Nice. The other question is, can you talk about the storage layer where the VMs are stored?
Sure. So for storage, we're using Ceph, and then it automatically creates 2 pools for you, which is replicated by default. And KubeVirt basically leverages the storage classes that gets defined as part of the CSI. And from there, it depends in which pool you want to create. You want to dynamically provision a PVC or dynamically provision from an image that you already have. And from there, you could decide how you want to store.
Awesome. Will the Kubernetes upgrade consider the resources deployed in the cluster, like a resource has changed its API?
Consider the resources. Like, what does that mean? Like resources that are part of the specification of a workload itself, or? Yeah. 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 Okay. I think that's something that I think you need to handle from the workloads that you're already deploying, right? So when you're moving and doing an upgrade to different Kubernetes version, if you're just doing an update from 118 to 126, for example, that has a long way in between as well. So the workloads that you're using, they also need to use the API, and Kubernetes is not killing the API. They normally deprecate it and move to the other version. So you can decide and see what workloads you deploy, and then based on that, you can choose which version you want to upgrade, then use the new API, and then do an incremental upgrade for the other versions. No, Juju doesn't know about the workloads that you deploy unless you deploy them using Juju. So for example, if you deploy Prometheus stack, just the Helm chart, it wouldn't know about it because it's outside its ownership. So some charms, they do specify you that it's incompatible, it would fail when you try to deploy, but it's something outside, then it wouldn't basically know about it.
All right. The next question would be, how would you integrate legacy VLAN networks with KubeVirt?
You can do that with KubeOVN. So KubeVirt basically, so the network part is outside because that's the CNI job that can do this. And KubeOVN can definitely do that. It can talk with the existing VLANs that you already have. And you can create VPCs on top of that. And then you can create different CIDRs or use the same VLAN as a pass-through as well for your VMs that are assigned to the namespaces.
Great. Where is RACD running? VM bare metal on switch?
Where's that? I don't see it.
What is this? Oopsie. Oh, yeah, there we go.
Okay. So the RACD basically running on a separate machine, or let's say the mass controller. In our example, it was running there. But in actual case, you can also separate this to a smaller machine or a smaller bare metal or even a VM if you want. But you probably don't want a VM or somewhere in the cloud because of the latency issues. You want to have something as close as possible to your bare metal so that you can bootstrap your bare metals as quickly as possible.
And the last 3 questions. Can I run Kubernetes inside a KubeVirt VM? Oh, Inception.
You can definitely use Cluster API to, what was it, this question? Or can I run Kubernetes inside a, yes, you can. If you want to do that, you can definitely do that. I've even tried something crazy, like Docker and Docker guys, for example, sorry. But I even tried KubeVirt inside a KubeVirt. You can do nested virtualization in it as well, which is something I don't know, you might not want to do, but to answer the question, yes, you can. Yeah, you can also do that.
Did you try Metal Cube in comparison to Moss?
We didn't try it, but we did eval it from a higher perspective. We didn't do a thorough eval for Metal Cube, but Moss is something which we also have been testing for about a year. and from on and off, from unattended upgrades. And Juju and the integration of MAS, and we're also using Netbox for our inventory, and we're using some open source tools. We can import our Netbox inventory to MAS as well, which is quite awesome. And there's also a cluster API provider for MAS. So you could also bootstrap Kubernetes clusters using the cluster API provider as well. So that was the reason, because it's more mature from our standpoint. Canonical is maintaining it. There's a huge community behind it. And that was basically our reasons to choose MAS.
So you've answered the two last questions at once. I will add one myself. What would you recommend then, using Cluster API or stick to Juju? What's your take on this?
I would personally stick to Juju for now. I've tried it out, Cluster API for MAS myself as well, but I think it's just a different way of doing it, because then it's a chicken and egg problem if I'm bootstrapping from scratch, and if I'm talking about the air gap installations and we're talking about edge solutions, then you need a Kubernetes version, which I can have Cluster API on top, and then I provision my MAS. This is why we didn't decide to go to this route.
Got it. Thank you very much. Thanks again for this great talk. And if I can ask you a big round of applause for our speakers, please.
Thank you, guys.